Great, it's recording now. Today we're going to talk about section 1.2, domain and range, and later we will talk about the average rate of change of a function. Okay, so let's start with this agreement that mathematicians came up with. It's about functions and how to determine the domain of a function whenever the function is determined or defined via a formula, okay? So if they give you a function f of x equals some mathematical expression containing x, then the domain of f of x by default, right, as an agreement, is going to be the set of all x such that f of x can be evaluated, such that f of x makes sense, right? Yeah, let's write down within parentheses here, such that f of x makes sense. So all the x values such that f of x makes sense are supposed to be part of the domain, okay? Part of the domain. This is easier to remember, probably. Makes sense. Okay. If you have a value of x that does not make sense for the formula, then you cannot consider that as part of the domain. Here is the first example. Find the domain of f of x equal 1 over x. 1 over x. This function is the reciprocal function, right? It's called the reciprocal function because it pairs up an input value with its reciprocal, right? And it's a well-known function. Now, let me ask you this, guys. This function, f of x equal 1 over x, can be evaluated for all real numbers except what the real number. Anybody could tell me or write on the chat for what real numbers this makes sense and for which real number it doesn't make sense. So except what value of x this will make sense. Anybody has an idea? You can write it on the chat. I see. I see on the chat someone is suggesting one value of x for which this wouldn't make sense. Gabriela, very good, excellent, right? Excellent. This formula 1 over x makes sense for values of x, any value of x except 0, right? Except 0, clearly, because 1 over 0 is undefined, right? If we try to evaluate this function at 0, it's undefined, we get in trouble, so that shouldn't be part of the domain, right? The rest of real numbers are okay for this evaluation. So then, according to this agreement, right, this mathematical agreement, what should be the domain of this function? Well, first in words, okay? It will be all real numbers except 0, right? 0. This is in words. First version of the domain in words. All real numbers except 0. But now, you know, mathematicians are minimalists, right? They don't like much words. Instead, they like symbols. So they have alternatives to express this by using intervals and then using some so-called set builder notation I will talk to you about. But first, how do you say this using intervals? Well, the idea is to set this value 0 on the number line, right? Number line with a hollow circle, right? Hollow circle because we are not considering 0, right? And consider it everything else. So you shade everything else. Plus infinity lives here or just infinity, and over here minus infinity, right? So when you write this as an interval, you have to start with minus infinity with parentheses because you never touch negative infinity, right? Then you go up to 0, parentheses because you are not including 0, right? Union, 0, comma, infinity. or plus infinity, right? It's the same. The idea of this parentheses, I'm gonna right here, is this. Use parentheses if you do not include the number, right? When the value is not included. When the value is not included. When the value is not included. You may say, Professor, what shall I use if the value is included? You use brackets. Later in the next example, I will show you, okay? But for now, parentheses, whenever you are not considering this value, 0, right? Very good. All right, moving on. Now, the same domain can be expressed using what mathematicians call set builder notation. How does this work, the set builder notation? Well, you start by considering here braces, and you consider here a property that defines this, right? What's the property that defines this? Well, the property is that x cannot be 0, right? So you go like this. The domain is going to be the set of all x such that this vertical segment means such that I will write it, x is not equal to 0. This is called set builder notation. Set builder notation. And try to understand that these three are equivalent, completely equivalent. And when you go over the homework or worksheets, you should be able to identify your answer with any of these three forms, right? For your domain, okay? This means such that this equal with a slash, not equal, okay? Very good. All right, so three ways to express our domain, right? All right, now let's move a little bit farther. Example 2. Suppose they say, find the domain of this function f of x equal 3 over x minus 2. Solution, the function f of x equal 3 over x minus 2 can be evaluated, makes sense, right? For all real numbers except, what is the number I should write here? Anybody could share on the chat? Or verbally? What number is not good for evaluations on that function? Hint, look at the denominator, right? Look at which one will give us 0 on the denominator. Yeah, try guys, try. Yeah, again, the hint should be, we should look at this guy, right? Notice when this will be 0, for which one? Someone posted an answer. Gabriela. Great. Excellent, excellent, right? Look, not hard to see that if we wonder, right, what number would break this function, this formula. That should be the number 2, because 2 minus 2, 0. 0 into 3, undefined, right? Yeah, very good, very good. Except 2. Now, how do you catch these 2 efficiently, quickly? Just look at the opposite of this, okay? So this is minus 2. You get the opposite. Okay? Opposite, 2. So that's the one that we're going to take away from the real number line. Okay, now, sometimes when I do this, say, Professor, is there any alternative to do this with, besides looking at the opposite? Yes, alternative. And it's a good alternative whenever it's the denominator is complicated. Set denominator equal to 0. Denominator equal to 0. That's a good alternative. Set denominator equal to 0. Equal 2, 0, and solve for x. And solve for x. If you do that, notice x minus 2 equals 0, right? Adding 2 to both sides of this little equation gives me x equal 2, right? Same as this. So it's an alternative, a nice alternative. All right, but one way or the other, you should say, or you should be aware that the domain of this function should be all real numbers, numbers first in words, right? Except 2, right? 2, the one that we got here, right? Either this way by taking the opposites or by solving this equation, except 2. This is in words, right? In words, first form for the domain. As an interval, remember to go from this forming words to an interval, you set this number on the number line, it's going to be the number 2 somewhere there. And you take everything else, you shade, right? Or you color here, everything else. And this as an interval should be the following, starting at negative infinity, right? Up to 2, and not taking 2, so use parentheses, right? Union 2, comma, infinity, right? Or plus infinity, doesn't matter. This is as an interval. Now, how this will be expressed using set builder notation? Well, braces here, the set of all x such that x not equal to 2. Not equal to 2. This is using set builder notation, right? These three are completely equivalent to each other. Excellent, excellent, guys. So now we have these two forms master. So let's move to more forms. Example 3. Sometimes the formula will be defined by a polynomial function or polynomial expression, better said, right? Your function will be defined as a polynomial. But now, what should be the domain of this? This is a polynomial function, right? Polynomial function. Polynomial function. So turns out polynomial functions are the nicest functions to work with in mathematics because the domain of these polynomial functions is all real numbers, all real numbers. Now, why is that? Well, notice that in order to see for which values of x this formula makes sense, enough to see that any real number can be a square, any real number can be multiplied by 4, by 2. There is no limitation, no restrictions when it comes to evaluate this function, right? So because of that, since these functions, since f of x can be evaluated without any trouble, right? For all real numbers, then its domain should be the set of all real numbers, right? All real numbers. Nothing is taken away from all real numbers, right? Now, as an interval, this, all real numbers, can be expressed as follows. Look, number line, minus infinity here on the left, plus infinity here on the right. I'm not taking away anything, so I'm shading and coloring everything, right? Everything, all the points on the number line. So this is expressed as an interval as follows, minus infinity, comma, infinity, or plus infinity, right? I am using parentheses because you never reach infinity, you never reach negative infinity, right? Very good. Okay, and now as a set builder notation, or using set builder notation, better said, this should be the set of all x such that x is a real number. You use a property, right, to express this set. Okay, great. So that's it. Now, I'm going to write very important note here for you to know. Note, very important note. As I said, right, these polynomial functions are one of the nicest functions in mathematics because they accept any input values, right? Any real number is good for this function. So note, domain of polynomial functions, domain of polynomial functions, the functions whose formula is given by a polynomial, right, is all real numbers, always. All real numbers. Right? So you see a polynomial on the worksheet, they ask you for a domain, immediately you respond or you answer all real numbers. Great. Okay, guys, moving on to something more challenging. Example 4. Find the domain of this function f of x equal x over x squared minus 36. What should be the domain of that function? Well, before we go over this, I'd rather you practice. Okay, remember, practice makes the master, guys. And then we will go over that form and we will continue practicing the worksheet. So look at the worksheet here on the notes, right? Also available on our website in Blackboard. And I want you to try first number 1 quickly, and then we will move on. Okay, so do this. They're giving you this question. Find the domain of the function f of x equal x squared plus 6. Hint, x squared plus 6 is a polynomial function, right? It's a polynomial function. So remember what we said about the polynomial function? So what do you think should be the answer for the domain of this polynomial function? Think about it and let us know if you know in the chat or verbally, doesn't matter. Aha, I see. The students, excellent, Gabriela, excellent, Sarah. Yeah, very good. You guys got it. Yeah, very good. Excellent, good. Yeah, we just said that as a property, right? If they give you a polynomial function, its domain is all real numbers, right? All real numbers. So this one, all real numbers, because this guy is a polynomial function, right? Yeah, I'm gonna write like a note here. F of x is a polynomial function, then D, right? Immediately, all real numbers, the domain. Okay, next, number 2. Can you try number 2 now? They say find or figure out the domain of this rational function, right? And the hint, guys, is when they give you rational functions, that look like fractions of polynomials, pay attention to the denominator, right? And then we gave some hints there. Pay attention to the denominator. Aha, Gabriela, again, very good. Sarah, very good, guys, very good, guys. See, you are sharp. Yeah, but let's see, let's check, let's explain, right? For everybody to follow. Excellent. Yeah. We said that it's all about taking away the opposite of this guy, right? The opposite of this guy from the number line, right? From the number line. So on the number line, you said the number 9. You say, Professor, why the number 9? Because it's opposite of this, right? Opposite of this. A quick shortcut, right? And you take everything else from the number line, right? Any other input value is good. Infinity, negative infinity here, right? So therefore, as an interval, the domain should be from negative infinity up to 9, right? We are not touching 9, so parentheses, union 9 up to infinity, right? Never touch infinity, so parentheses again. So this is it. They chose interval notation. So quickly we realize it's this guy, right? Excellent. Yeah, very good. Yeah, this guy is similar. So you can do it at home. Okay. I'm going to show you now how to deal with this form. Okay. When you have some polynomial showing squares or even cubes there. So let's go back to a lecture and deal with this form. So what happens if they give you something like this? Let's see. Find the domain of this function f of x equal x over x squared minus 36. Okay. Solution. The idea is to factor the denominator. Professor, why you are factoring the denominator? Well, because if you factor the denominator, you will see clearly for which values of x this expression on the denominator, right, does not make sense. X squared minus 36, remember, this is factored using this guy. It's called difference of squares, right? It's a way to factor the difference of squares. This is 6 squared, right? So x squared minus 6 squared factors as x minus 6 times x plus 6, right? Great. Now, then when you look at these two denominators, first at this and then at this, right? Know how to see, right? That f of x can be evaluated for all real numbers except this guy, opposite of this guy, right? Opposite of this guy, 6. Opposite of negative 6, 6. And opposite of this guy now, negative 6, right? These are the two input values that are not good for this function, 6 and negative 6. I took it from the opposite, right? Alternative, set this equal to 0, right? Alternative here. If it's not easy to pick up the opposites, right? Sometimes the denominator might be complicated. Then set this equal to 0. From there, you will get them. Okay. X equals 6, x equals negative 6, right? These are the two guys that you have to take away from the number line. So then the domain should be first in words, all real numbers except 6 and negative 6, right? That's it, except 6 and negative 6. Now, how you write this using interval notation? Using interval notation, remember, you have to set now these two values, 6 and negative 6, on the number line, right? 6, negative 6, right? Let's make this negative 6, this 6, so there is like an order there, right? Doesn't have to, but for the purpose of the explanation, right? Will be better. Yep. So here, hollow circles, empty circles, right? And you shade or you color all the rest, right? Minus infinity here, plus infinity here. We're coloring all the rest. Or shading, or yeah, or taking all the rest, right? So the domain should be as an interval, starting at negative infinity, going up to negative 6, right? Parentheses, because we are not taking 6, union 6 up to infinity, right? Up to not up to infinity, negative 6 up to 6 first, right? These two, and then union 6 up to infinity or positive infinity, doesn't matter. Yeah, this is good. This is it, right? Look, 1, 2, 3 intervals now, right? Because you are taking away 2 points. Very good. Now, using set builder notation, this should be the set of all x such that x not equal to negative 6 and x not equal to 6, right? Set builder notation, all right? You see, these three completely equivalent, right? Very good. So now, guys, with this background, I think we can go back to the worksheet and deal with this form once and for all, right? The one that we skipped, this one, this one. Can you try this? Make it bigger so I can see. Can you try this, guys? And tell me what should be the answer? Take your time and try it out. Very good. And then we will do another one, which is a little bit challenging. Hint, factor, right? Factor the denominator. That's the hint. Factor denominator. Let's see. Sarah, yeah, you made my day. Excellent, excellent. Very good, very good. Yeah, use factorization, right? Use factorization. Very good, very good. Very good. So if we factor this, right? Factor, we're gonna get that this function is just this, x over x minus 7 times x plus 7, right? I'm using difference of squares, right? This is 7 squared, right? Notice. Now I pay attention to the opposite of this guy and the opposite of this guy, right? These are important because we have to take them away from the number line. They will give us trouble when we try to evaluate this function, right? These are not good inputs. So basically, you just draw a number line, set -7 here on the left of 7, right? Important that you set them in order. And then hollow circle here, or empty circles, right? And then you shade or you color the rest. Everything except for -7 and 7. This is negative infinity, this is positive infinity, right? So now, as an interval, this should be from negative infinity to -7, union -7 to 7, union 7 to infinity, right? But notice that they have chosen this time set builder notation, So let's do that with set builder notation. So it will be the set of all x such that, and here the property, right? X not equal, remember this equal with the slash means not equal to what? Not equal to 7 and not equal to -7, right? So they have just put a comma here, 7. Very good. This is it, right? Follow, guys? Yeah. Try to remember this for your homework. Okay, now I'm gonna dare you to do this one, and then we will deal with the radicals too. I will show you next, but let's try to do this too to clarify. This will help you also in your homework. What about this? Again, hint, factor. Hint, factor denominator. Factor denominator. Yeah, very good, very good. And for that, recall that you have to look for two numbers whose multiplication -10, whose sum is 3, right? Yeah, try this, do some trial and error, and you should figure that out. Yeah, very good, very good. And after factoring, you pay attention to this number, you take the opposite, remove them from the number line. Basically, we are done, right? Mhm. I see. Yeah. Excellent, excellent, Sarah. Very good, very good, very good. Excellent, excellent. Yeah, you got it. Mhm. Yeah, let's do it together, right? We are practicing. So we're going to factor this denominator. Two numbers whose multiplication is -10, whose sum is 3. After some trial and error, you will see that these numbers are 5 and 2. But since you want the sum to be 3, this guy has to be negative, this guy has to be positive, right? 5 plus -2, 3. All right, now you pay attention to the opposite of this and the opposite of this, right? The opposite of this. These are the ones that you have to take away from the number line, right? So the domain will be all real numbers except opposite of +5, -5, opposite of -2, +2, right? Yeah, so maybe I should point that out, right? So when you do your homework, you will use this. How I found this -5, opposite of +5. How I got this +2, opposite of -2, right? Opposite. All right, very good, guys. Now, this is in words, but they have chosen here the representation of the domain as an interval. So let's translate this into an interval. For that, not a problem, shouldn't be a problem, because all we need to do is this, right? Let's draw the number line here. In order, -5 first, on the right somewhere 2. Hollow circles, because we are avoiding them, right? We don't want those input values. So shade or color the rest, and translate this into an interval. Look, start with -infinity, right? Go all the way up to -5, parenthesis, because we're not including -5, union, -5, go up to 2, do not include 2, so parenthesis again, union, from 2 up to infinity, right? Or positive infinity. And this is very good, this guy. Excellent. Great. Now I'm going to give you a tricky one, okay? Very tricky, but I hope you will handle this, do this. It's surprising the result for this domain, but it's doable. So I'm going to rewrite here f of x equal x squared over x squared plus 15. Yeah, notice that this denominator cannot be factored, right? Cannot be factored. It's unfactorable. It's a prime polynomial. But this should tell you something, right? If you cannot factor the polynomial, then you are not going to be able to find these values, right? That you have to take away from the real numbers. So therefore, there's nothing to take away from the real numbers, right? So the domain should be just everything. So anyone could figure out what's the domain of this function, just based on what I said, and then I will give you some notes there for this form. Yeah, I will comment on that, right? Yeah, note, right here, note. X squared plus 15 cannot be factored. Even if you set x squared plus 15 equals 0, you will end up with nonsense there. Look. X equal this, not a real number, right? This is not a real number, not a real number. So no solution for this, right? So In that case, guys, when you cannot factor, when setting this equal to 0 means nonsense, right? It means that this will never be 0. This will never be 0, right? So therefore, we will be always safe, right? So you have to choose this, all real numbers. That's the domain, okay? Yeah, very good, very good. So another way to explain this, to support this, note again, is this. X squared is greater or equal than 0, right? For any value of x, positive or negative. Notice what happens if you add 5 to both, 15. So 15. Both sides of this inequality. You will end up with this, x squared plus 15 greater or equal than 15. So never 0. At worst case scenario, this will be 15, this expression, right? So we are safe. For those cases, you have to answer that the domain is all real numbers, right? Nothing to take away from the real numbers, so all real numbers are the domain, okay? Whenever you cannot factor. All right, guys, so now we have to deal with these radicals, right? This is the other form that we have to master, the radical form. So let me show you, let me explain this first to you with a nice example on the notes, and then we will go back there. Example 5. Suppose they ask you to find the domain of this function, f of x equals square root of x minus 5, based on the agreement, right? So how you proceed? Well, recall that square roots are defined, make sense, right? Only if the radicand is positive. Only if the radicand is positive. And what is the radicand, Professor? The radicand is the stuff that goes inside the radicand. This is the radicand. Radicand. So as long as this is positive, your function makes sense. Could you give an example, concrete example of that, Professor? Yes. Suppose you have your calculator, your scientific calculator, and you try this, a square root of the number 16. That is the number 4, right? But what if you try a square root of negative 16, undefined? When you work with real numbers, this doesn't make sense. You may say, Professor, but I learned complex numbers. Yeah, later on, we will see complex numbers. We're using complex numbers, this makes sense. But right now, we are dealing with real numbers. So whenever the radicand is negative, this will be undefined, okay? Okay, great. Now, this radical function will make sense, will be defined only if the radicand is positive, right? So what you have to do here is this. You have to set this to be greater or equal than 0 in order to find your domain, right? That's going to be the idea when you deal with radicals. Make sure that the inside of the radical is positive. For that, you're going to set this guy, x minus 5, greater or equal than 0, right? Because as long as this is positive, this will make sense, right? Then you solve this inequality, and then you get that x is greater or equal than 5, right? And this should be your domain. So in words first, you can say the domain is all real numbers, greater or equal, than 5, right? This is in words. But remember, mathematicians don't like words too much, right? They like to express things using symbols, intervals. So how do you express this? Using intervals. Well, again, guys, use the number line. On the number line, set this important value 5 somewhere. 0 is in the middle, 5 should be somewhere here. Now, this time, since I'm including 5 as part of my domain, right? Because 5 is okay. 5 minus 5, 0. Square root of 0 still makes sense. It's 0, right? Since I'm including 5, then when you set this, you use a solid circle, a shaded circle, okay? Instead of a empty circle, solid circle, shaded circle. And then you're going to look at this direction, the direction of this inequality. It's pointing to the right, right? To the right. So you follow that. So you shade or you color everything to the right of 5. Here is where positive infinity is, right? So what should be this in interval notation? Well, starting at 5, right? Starting at 5, including 5. So now I'm going to use brackets, right? Up to infinity, parentheses. You never reach infinity, right? So here, note, use brackets, right? Whenever you include the value. Use brackets when the value is included, right? Okay. Parentheses when you don't include the value or the number, brackets when you include. All right, this is using intervals, right? This bracket 5 comma infinity is the domain of this function. But now, how do you express this using set builder notation? Set builder notation, let's see. For set builder notation, you have to do the following. Open up braces, you will say the set of all x such that, and here the property, x greater or equal than 5, right? And then close braces. That's it. So the hint is, guys, when dealing with the square root functions, set radicand to be greater or equal than 0, this radicand inside part of the radical, and solve for x to determine the domain, right? That will be the method, the technique to determine the domain. All right, so now let's go back to our worksheet, right? So we can master this part, this form. And then let's move on, guys. I'm gonna give you this one. It's a little bit tricky, but I hope you can handle this, do this. Can you try this? Figure out the domain of this. I'm gonna give you the hint, okay? Hint, set 3 minus x to be greater or equal than 0 and solve for x, right? And solve for x. It's a tricky inequality. Yeah, why are you saying that? Well, because this is the radicand, right? You set it greater or equal than 0, that will determine your domain. So try guys, and let's see if you can do it. Remember, when you deal with inequalities, when you divide both sides of the inequality by a negative number, you have to switch the direction of the inequality, right? Recall that. We're working on number 5, right? Try to do this. And it will help you also in your homework. It's a question where I attached a video there in the homework to help you out. So if you cannot do it directly, watch the video. After watching the video, it will be clear what to do. I see 2 students participating. Gabriela, very good. Sarah also, very good, guys. Yeah, you made my day. Excellent. How you deal with this inequality? Well, let's do it together, right? To solve for x here first, I'm going to subtract 3 in both sides, okay? I'm gonna end up with this, minus x greater or equal than minus 3. But then what, Professor? Then what? Look, this is minus x minus 3. I need to get rid of this negative sign, right? For that, I am going to divide both sides of this inequality by the number -1. But that comes with a price. If your divisor is negative, guys, you have to switch this or flip this inequality, right? This way. So this will be x less than or equal than -1 into -3, +3, right? Yeah, great. So this should be the answer. This should be the property that defines the answer. They have chosen set builder notation. So this should be the domain, right? The domain. The set of all x such that x less than or equal than 3. Very good. Excellent, excellent, guys. Okay, so now number 6. Number 6 is very tricky, but I hope you will figure this out. Yeah, we're gonna do this number 6 now. So try to do this, guys. Do this. The radical part is not that tricky, but what is tricky is that this is like a fraction. So do this now. Yeah, try this number 6. While you try that, let me create some space here. Let me remove this and then just put this here this way. So we can do the answer there. Yeah, opposite. Opposite, right? Yeah, and then we can have this space to do that. Yeah, the hint is set this greater or equal to 0 first, but then consider that it cannot be 0 because its radical is placed on the denominator, right? On the denominator. Think about that. Yeah, no, cannot be 10. Yeah, just, and then you will figure this out. All right, for number 6, let's see. Yeah, hint, look at this part, right? Which one, right? You have to think about this, right? Cannot be 10 because if it's 10, 0 on the denominator is not good for this fraction, right? So that's the kind of the trick there. Okay, guys, let's go over this together, okay? So we can move on to more forms. When you see a radical, remember, immediately you set the radicand, x minus 10, greater or equal than 0, right? Greater or equal than 0, because that's the only way for radicals to make sense, right? When the radicand is greater or equal than 0. So solving this this inequality, I intend to both sides, x greater or equal than 10, right? Now, this should be my domain, right? Everything bigger or equal than 10. But turns out this radical is at the same time the denominator of this function, right? It's on the denominator. So I'm gonna write here, but x cannot be 10, because if it's 10, 10 minus 10, 0, right? The opposite of this is not good, right? Cannot be 10, right? So then domain, the set of all x such that x greater than 10 is strictly greater than 10, right? Not 10. So we go with this, right? You follow, guys? Yeah, it's a little bit tricky, but again, doable. Just consider that if the radical is on the denominator, instead of greater or equal, you should use greater than right here. Very good, very good. Let's clear this up. Yeah, and then let's continue with finding the domain and range from graphs of functions. The domain and range of a function can be determined by looking at its graph. How? Well, in order to find the domain first, you are going to ask yourself, right? how far I can go to the left, how far I can go to the right. What is the largest value and the smallest value horizontally speaking, right? I know how to see, guys, that if you look at this graph here, that is just this. From here to here, right? This. Yeah. From here to here. The lowest X value here, and here the largest X value, right? Now, the lowest X value here is clearly 1, 2, 3 to the left, -3, right? The largest is 1, 2 to the right, 2. I am using brackets because look at this, it's a solid circle, right? I have to use parentheses here because look at this, it's an empty circle, right? So bracket -3, 2 should be the domain of this function, the one that has this graph, right? Great. Now, sometimes students and the professor, is there another way to do this? Well, if you like physics, for example, you can think of beaming light in this direction and try to catch the shade that this will produce. Well, this will be the shade, but if you beam light in this other direction, this will complete this part, right? So look at the shade. That also helps, okay? But one way or the other, you should come up with this, right? From -3, which is here, to here. Bracket, parentheses. Great. Range, how you catch the range. For the range, similarly, you're going to look at the highest or largest output value here and the lowest output value here, right? Highest, lowest, highest Y value, highest Y value, lowest Y value. Okay, this will determine the range. All right, so the range should be then starting here at -1, 2, 3, 4, right? -4. Notice hollow circle. So I got to start with parentheses -4, comma, all the way up to 1, 2 up, but with brackets, right? With brackets because it's a solid circle there. Okay. Now you may say, Professor, any other way to do this? Well, if you want another way, think of beaming light now horizontally this way, beaming light, and try to think of the shade that will be produced if you beam light in these horizontal directions, right? The shade will be this piece together with this piece, right? This whole, right? Maybe we should highlight it. This is what you will get, right? For the shade. Very good. Now, equivalently, if you look at the shade horizontally this way, right? Huh? That sometimes helps too. Okay, great. So domain and range from a graph. It's not that difficult, guys. Now, let me see if you can do one of this. I'm gonna start with this one. Can you try? Yeah, actually, let me do this, the first one for you, and then I will ask you to do the others. I will start with the first one here. Find the range of this function, the one having this graph. Okay. I recall that the range is captured by the largest value and the lowest value of y's, right? The output values. So clearly for this graph, these two are the largest and the lowest values, right? So from there, I can say that the range should be the lowest y value is clearly -4, as you can see there, right? -4. And since this is a solid circle, should go with brackets, right? Then all the way up to the number 2, you can see, right? 1, 2, so 2. Since this is part of the graph, right? The number 2, I should use also brackets, right? Done. Okay. It's not that difficult, guys. Try this, number 2 now. This is going to help you also in your homework. Find the domain now, not the range. I did it with a range, right? Highest, lowest, right? For the domain, remember the lowest on the left, the largest on the right. Someone already figured this out. Very good. Man. You got it. You got it. Excellent, 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 right? Yeah, try, guys. Try. Yeah. Remember, for the domain is how far you can go on the left, how far you can go on the right, right? And this idea will help us also when we go over our Desmos activity 1 next week, I think. All right, great, excellent. Yeah, very good, man. So you look at the graph, right? Now, since they want the domain, this was for the range, right? Maybe I can highlight this, range. But now domain. For the domain, I have to pay attention to this, how far I can go to the left, how far I can go to the right, right? It's horizontal distance. To the left, the farthest I can go is here. To the right, the farthest I can go is here, right? And let's be formal there. Yeah, great. So now you could try to catch those numbers, right? Those values. On the left, clearly -3, right? -3 on the left. So domain. On the left, -3. And I gotta use a bracket because this is a solid circle. On the right, 3. I gotta use brackets because solid circle again, and then it's done, right? Very good, very good. And this is this guy. Excellent. Can you try number 3? It's a little bit tricky, but try it. I think you will handle this. The range, figure out the range of this function by looking at its graph. Range. Can you do that? Hint, try to look at the lowest value of the y's, right? The output values, the second coordinates, right? And the highest value of the y values or output values, right? Lowest and highest for the range, right? I see more students. Sarah, excellent. Ma'am, also excellent. Yeah, you guys made my day. Excellent. Very good. It's not that difficult, right? The lowest you can go here is this. The lowest you can go here is this, right? Notice nothing is below this guy, right? This point. So the lowest clearly is -2, right? You start there, -2, the lowest. Now, bracket, because this point belongs to the graph, right? Belongs to the graph. Comma, the highest I can go in this direction is this point, not this point, right? But this point, higher. 3. That's it. Yep, that's your range. And then when you look through, it's here. Excellent. Guys. So now let's continue. Let's talk about basic functions. We're going to call them parent functions, and they will help us for what is coming up. First, the identity function. The function f of x equal x, or equivalently y equal x, when graph pairs up the input value with itself, for example, 1 with 1, 2 with 2, -1 with -1, -2 with -2. As a result, give us this diagonal line, right? Diagonal line. That should be the graph of the identity function. Try to remember that. Try to memorize that. Now, Professor, what if I forget? No problem, guys. Remember, I gave you this tool. In case you are not sure about the shape of a graph, use this Desmos basic graphing calculator. Look, that shows the graph of the identity function y equal x, right? Diagonal line. Great. Now, the next is the parabola, the graph of a quadratic function in its basic form, y equal x squared. Shows this parabola, U shape opening upward. It's called a parabola. Again, if you want to double check, always use this tool. This is your parabola, right? Opening upward. There we go. F of x equal x squared, another parent function. Cubic function, f of x equal x cubed. When you graph the cubic function, remember we talked about this in the first lecture, you get this chair-like shape, right? Like a chair where you sit, right? Again, guys, if you want to double check, confirm that that's the shape, look, y equal x cubed, this is it, right? Looks like a chair. It's a cubic function in its basic form. Next, the constant function, f of x equals c, where c is some number, some real number. Could be positive. In that case, the graph will show this horizontal line above the x-axis. In case c is negative, horizontal line below the x-axis. Again, you want to check this out. Let's say y equal 4. Horizontal line at level 1, 2, 3, 4 here, right? If x is negative, let's say y equal -3, the horizontal line will appear now below the x-axis, right? But what is important is that you recall that for constant functions, the graph is a horizontal line. Great. Okay, with these functions in mind, right? You should memorize this shape, right? We can talk about piecewise function. What is a piecewise function, Professor? It's a function that requires more than one formula to be defined. More than one formula. How does it work? Well, suppose you have this function f of x being equal to x squared, the quadratic function in basic form, if your input value is less than or equal than 0. And the identity function if your input value is greater than 0. Piecewise function. Now they say compute f of -2, compute f of 3, and graph your piecewise function. How do you do that? All right, first, f of -2, what is that? F of -2 is going to be, since -2 is less than 0, what we get when we substitute -2 into this function, right? Into this function. Why I'm using this formula, Professor? Well, because -2 is less than 0, right? Yes. -2 squared. -2 squared is -2 times -4, right? +4. 4. 4. Now, what if they ask you to evaluate this piecewise function at 3, f of 3? What is f of 3? Well, for this evaluation, I have to use now this formula. Why? Because 3 is greater than 0, right? Greater than 0. For input value greater than 0, use the identity function. So evaluating at the identity function gives me just 3, right? 3. Great. Now, they want you to graph. To graph, you have to recall this main graph, which are called parent graphs, right? Parent functions. Look, we need the parabola here, and we need the identity function, right? But where you draw your parabola? Well, for x less than or equal than 0, less than or equal than 0, you should consider a parabola. The parabola, this U shape, right? Completely. But we don't need this completely. We need just part of it. So we need the parabola for values of x less than or equal than 0. So we need the parabola up to here, right? Up to here. There we stop. We don't need this part. Only for x less than or equal than 0. Now, if x is greater than 0, then we're going to need the identity function. But the identity function has as its graph this diagonal line, right? This is the graph of the identity function in full, but I need just this part because this is for x greater than 0. So I take a hollow circle there and draw this diagonal line, right? That's it. These two together will be the graph of this piecewise function, okay? Okay, guys. 0, important part. Now you may see, right? This was solid circle, this was empty circle. The empty circle covers the hollow circle, so you are not going to see holes there, right? Yeah. Now, when I do this, sometimes students ask me, Professor, is there a way to graph this using our tool, our Desmos graphing calculator? Answer, yes, guys. How? I'm going to show you now. And you're going to use this for your homework probably if needed. Bring it up first, right? It's in our website. Under Desmos tab, right? If you want to graph a piecewise function, you simply do this. First, graph this part, x squared, right? Y equal x squared. Whole parabola, right? But now you want this just for x less than or equal than 0, right? Write that condition, less than or equal to 0 within braces. This is how Desmos graphing calculator works. So this part, you should write it here within braces. And you can see now that it graphs just the left part of the parabola, right? Great. Done with this part, right? Now for the identity function, y equal x, again, within braces, write for x greater than 0. So x greater than 0 within braces. And then our basic tool will work and will give us, right, parabola, and then this identity function, the diagonal line, right? Use it if needed. Okay, great. Now, let's continue. Let's do some work. For example, here's some evaluations for you to do, guys, easy ones. Can you try number 1? Evaluate this piecewise function at x equal -3. F of -3. Can you do this? Remember, look at where -3 is, right? If it is less than -1, or if it is greater than -1. And according to that, you have to use a formula, right? Formula. Go ahead. I'm going to give you a hint. I'm going to draw -3 on the number line. Here. Together with -1. Let's say this is 0, -1, -3 is here, right? So since -3 appears on the left of -1, -3 must be less than -1. So consider that and choose your formula and then just go ahead. Okay, guys, so let's do it together then. Clearly, since -3 is less than -1, we gotta choose this one. This one, right? This is for negative, for values of x less or equal to -1. Since it's less, use this. So this will be 3 times -3, and that is -9, right? -9, so we're talking about this guy. Can you try this, number 3? Find f of 8. And try to see in which of these intervals -8 is, right? And then based on that, you use the formula. And if you have questions, as usual, guys, just let me know, either writing on the chat or verbally. I will answer your question, okay? Okay, so hint, look at this part, right? This is saying that for x greater or equal than 8, you should use this formula, right? So this is the one that we have to use, right? So 8 times 8 equal 64, right? Yeah, very good. So 3. This ones you can do it at home. Okay, I hope you will be okay with that. Now let's do some graphing, right? Let's do this one. Let's try this. Let me show you how to go over this. Suppose they want you to graph this, right? Notice, I see here students posting. Mhm. Okay, very good, Gabriela. Yeah, your question, let's back up. Why we are choosing this formula, right? Well, because notice that this x minus 1 or x less than 1 is telling us that for any number that is less than 1, right? Let's say 1 is here, right? Less than 1 means hollow circle for any of these numbers. Any of these numbers, use this formula. This guy is saying, right, for any number between 8, solid circle, remember, because greater or equal, and 11, solid circle for any of these guys, any of the, including 8, including 9, including, 11, you should use this formula. Now it's better because of this, right? Be greater or equal for any of these. If they ask you for f of 9, you should use the same formula, right? F of 10 up to 11. If it's bigger than 11, you have to use this other formula. Excellent, excellent. Yes, it gives you a place where you should look at for the input value. 8 you have is in here in this interval, so therefore you have to use this formula. Excellent, excellent. Now better. Yeah, for the other formulas, it depends where they, for example, right? If let's say they say f of 12, then since 12 is bigger than 11, then you have to use this formula, right? It will be 8 minus 4 times 12, right? You follow? Yeah. It's just that you have to get it. Excellent, Gabriel. Very good, very good. Yeah, so let's just erase this as a reference. Yeah, I know these piecewise functions give trouble, but use your Desmos graphing. Yeah, you're welcome. You're very welcome. I'm happy to help. Yeah, and then let's do this, right? Yeah, -1 if x is greater or equal than 1. So if x is greater or equal than 1, which is here, greater or equal than 1 is the function -1, the this is called the constant function, right? I'm gonna go solid circle and let's do it right here for -1 to the right? If x is less than 1, is this function y equal x plus 4. 4 is the 1, 2, 3, 4, the y-intercept, right? And then from there, you draw a line with a slope 1, right? With the slope 1. Okay, great. So like this. Then, therefore, this should be a graph, right? Yeah, but only up to here, right? Up to there, up to here, because they are saying that it's up to for values greater than less than 1, not at 1. At 1, this will give you 5, right? So we should avoid that 5, right? Yeah, we should avoid this 5. So very good, right? And then here it continues forever. Yeah, this should be the graph, so you should use it here. Very good, very good. Yeah, this one, no 1, and then the constant, so this should be D, right? Or you can use the tool that I gave you and figure it out. It can work like that too, okay? Check that out. Now this one, it deals with domain and range, right? So on the graph, based on the graph, find the range of this. Can you find the range of this using the technique that we used before? You have the graph, right? Maybe we should do it quickly so we can move on with the next part. Look, since they are asking me for the range, right? I just pay attention to the largest value, the highest output value, and the lowest output value, right? Highest and lowest. Notice that the highest output value is here, right? Highest. And the lowest is here, right? The lowest is here, so here. So this should determine the range. Range equal from 0, right? The lowest 0 up to 8, right? Up to 8. So 0 bracket, because 0 is part of the graph, up to 8. But 8, notice, is not part of the graph, right? There's a hollow circle there. So you have to put 8 here and attach to 8 parentheses, right? So we don't know this. Okay, guys.